Hello, Shanghai International Blockchain Week. I'm so happy to be here with you again. This has become a kind of tradition for me. Today, I'm going to talk about the first real world computer, the Internet computer blockchain. So we stand on the cusp of another momentous phase in the Internet's history. Back in the early 1990s, the Internet was only a network, and then the World Wide Web was invented. Initially, the World Wide Web was simply used to serve content from servers into users' web browsers, and that was Web 1, best characterized by the word read. Towards the end of the 1990s, social media appeared, and users began to upload content to servers so that it could be consumed by other users. And that was Web 2, and that's best characterized by the word write. We're now entering the Web 3 phase, and this is all about tokenization and providing users with direct ownership over assets and also ownership and control of the internet services that they use. And this new Web 3 phase is best characterized by the word own. And to make this Web 3 dream a reality, we're going to need a real world computer. Now, this is something I've been working on for a very long time. I've been in blockchain for almost 10 years. And for me, this all began in 2014 when I was part of the Ethereum community and realizing for the first time that a blockchain could host software, computation, and data. And someone introduced this concept of a world computer. And this idea that humanity might share a single massive world computer greatly inspired me. And in 2015, I started the Dfinity project to propose technical ideas that might enable a world computer network to be created. Originally, the intention was that these ideas would be used by Ethereum, but eventually Dfinity became a standalone project. Scroll forward to May 2021, and the Internet computer blockchain finally launched after many years of R&D. So in our vision for Web 3, blockchain is the platform and the cloud. That means that we're going to build services that run entirely from the blockchain using smart contracts, a new kind of smart contract that is much more powerful than those that went before, that can process HTTP requests and serve interactive web experiences directly to users, so that you can build Web3 services without any need for cloud services or traditional IT. Another aspect of this new Web3 world is that communities will own online services via decentralized autonomous organizations, or DAOs. So we can see in this diagram that some smart contracts have been used to create the service, and other smart contracts have been used to create a DAO that controls that service. So that DAO will actually update the service according to the wishes of its community of users and developers, and so on. And end users will interact both with services and with the DAOs that control those services. So you may be asking, is this possible on blockchain? And I'm very proud and pleased to tell you that, yes, it is using moon math and super advanced cryptography. And in fact, it's working today, and it's been proven in production. So the internet computer is a blockchain that's very, very different to any other blockchain in existence today. It works in a completely different way, and it relies on different cryptography. The internet computer actually runs on special devices called node machines, in much the same way that the internet runs on routing devices. And these node machines connect over the internet using Internet Computer Protocol to form the Internet Computer, which is a general purpose blockchain. And that Internet Computer hosts canister smart contracts, which of course are used to build systems and services. And you can pretty much build anything on the Internet Computer. You can build a social network on the Internet Computer. And this, of course, is available today on Earth, even though it's built with moon math. And there are already thousands of services running from the Internet Computer. We're making this Web3 dream where a service runs from the blockchain under the control of a DAO a reality. The other great news about the Internet Computer is that it is orders of magnitude more efficient than pre-existing blockchains and other blockchains in existence today. So it greatly reduces the CO2 emissions associated with the blockchain. In fact, we believe that building on the Internet Computer blockchain will be more efficient than building on traditional IT. So if you care about carbon emissions in the end, you'll choose to build on blockchain. And yet, the Internet Computer provides all of the usual properties that you expect from a blockchain. It provides the security guarantees, the liveness guarantees. It can run autonomous code. It has censorship resistance. It's decentralized, and it's very highly programmable. I want to give you a sort of visual demonstration of quite how efficient the Internet Computer is. So this compares the cost of data storage on Ethereum versus Solana. On the left, the large box shows the cost of storing a gigabyte of data on Ethereum. And it goes up and down, but when I created these diagrams, it cost about $100 million to store a single gigabyte of data on Ethereum. When the price of Solana was about 150, it cost about $500,000 to store a gigabyte of data. So let's compare Solana with the Internet Computer. So there on the left now is a box representing the cost of storing a gigabyte of data on Solana, $500,000. And on the right is a tiny, tiny 3 pixel by 3 pixel box that represents the relative cost of storing a gigabyte of data on the Internet Computer. So whereas Solana costs about $500,000, on the Internet Computer, you can store a gigabyte of data for about $5. And that cost is constant. It doesn't depend on the price of ICP. So let's put that in practical terms. How much would it cost to store one phone photo on the blockchain for 1 year? On the Internet Computer, you can store a phone photo for about 1.6 cents a year. On Solana, it'll cost about $1,500 a year. And in this example, a phone photo is about 3.3 megabytes. So clearly it's far too expensive to store a phone photo on Solana. And it's important to remember it's not just files that we need to store on the blockchain, it's also structured data. So if you wanted to create a social network on the blockchain, you'd have to store all kinds of structured data for each user to enable the news feeds to be created. Now, I invite everybody listening to go to the Internet Computer's dashboard. It's at dashboard.internetcomputer.org, and check out some of the incredible stats. So, for example, on the 9th of September, when I looked, the Internet Computer was processing about 5,000 transactions a second. Some of those were update transactions, some of them were pre-finalized query transactions. That gives a total of about 450 million transactions a day. So the Internet Computer is processing almost 500 million transactions a day currently. But sometimes what you hear in the crypto press doesn't reflect that reality. So, for example, the Solana founder recently said Solana processes more than 30 million transactions per day, and this is more than all other chains combined. Well, obviously that's not true, because 30 million transactions a day is far less than 500 million transactions a day. And the Solana founder used that as an excuse for the Solana blockchain suffering various network failures. I'd love to remind everyone of the important statistic that the Internet Computer has never suffered a network failure. Now, today, some claim that Web3 and the cloud are compatible. So today, when you use a Web3 service, usually it's running on Amazon Web Services, which stores 99% plus of the data and performs 99% plus of the computation involved. And the blockchains are only used to store a few tokens like NFTs. And it's an important question to ask. Is this the future of Web3? Is this a good architecture? So here's a diagram showing today's 99% on-chain architecture for dApps and services. And we can see that they involve a wallet that comes from the Chrome Web Store, like MetaMask. We can see that they involve web servers and databases on the cloud, and oftentimes blockchain nodes that are themselves running on the cloud. Now, we say this is very bad. Google could ban the blockchain wallet. That's actually happened to MetaMask a couple of times in the past, preventing people accessing Ethereum dApps. A malicious insider at Google could change the code and steal everybody's tokens. Obviously, if your Web3 service is running on the cloud, it might get hacked. And that kind of thing's happened many times before, with the result of the loss of user tokens. And of course, it could go down if Amazon Web Services suffers an outage. Even running blockchain nodes on the cloud is a bad idea, because if you have something like MetaMask interacting with Ethereum nodes being run on Amazon Web Services by Infura, say, well, if Amazon Web Services suffers an outage, so will MetaMask, and that's happened in the past too. But perhaps the biggest problem of all with running in the cloud is that a DAO runs on the blockchain. A DAO is created by smart contracts. And smart contracts running on the blockchain cannot control and configure software that's running in the cloud. So it's impossible to give a community ownership and control over an online service if it's running on Amazon Web Services. The people that control that service are the developers who put their credit card into Amazon Web Services and who have the rights over that account. There's another problem with that, which is that those developers who control the cloud account used to provide Web3 services often become legally liable for the service and can be accused of being money transmitters, issuing illegal securities, and so on. So a real world computer solves these problems. And now, thanks to the Internet Computer, you can build out the real Web3 Internet. Now, one of the really fantastic things about Internet Computer or ICP smart contracts is that they can create transactions on other blockchains without a bridge. And this is thanks to the Moonmath chain key cryptography that powers the internet computer. That means you can use the internet computer as a cross-chain Web3 orchestration layer, and you can host data and compute on the internet computer blockchain and take it off the cloud. You can host and serve your dApps user experience on the internet computer. ICP smart contracts can actually directly process Bitcoin on the Bitcoin ledger. There are no bridges involved. And that means you can create native Bitcoin DeFi, which is very, very exciting because of the sheer amount of liquidity on the Bitcoin network. So using the internet computer, you can get rid of the cloud and traditional IT from your existing Web3 architecture. Internet computer smart contracts are called canisters, and they're actually software actors. And this means that they can run in parallel, and your dApps can scale, the blockchain itself can scale. They can do all kinds of interesting things like process HTTP requests. And internally, an internet computer smart contract is a bundle of persistent memory pages and WebAssembly bytecode that runs in those memory pages. And you can create this WebAssembly bytecode by compiling a large range of languages. The two most popular languages on the internet computer today are Motoko and Rust. For the technical among you, I recommend you take a look at the Motoko language. It was created by a team led by Andreas Rosberg, who was one of the co-creators of WebAssembly itself. And because of that, Motoko is designed to take great advantage of WebAssembly, as well as all of the native features of the internet computer. Now, the internet computer introduces something called reverse gas. And this is something that everybody should know about. On every other blockchain in the world, the user pays for every single computation. And that's why you need these plug-in wallets like MetaMask. Every time you want to interact with the blockchain, you have to pay a fee. On the internet computer, smart contracts work within something called the reverse gas model. That means the smart contracts pay for their own computation, not the users. And you have to charge smart contracts up with something called cycles. It's equivalent to charging a Tesla with electricity. And when the smart contracts perform computations or store data, they burn through these cycles, and eventually they have to be charged up again. So because smart contracts pay for their own computation, that's enabled us to really pursue the original Satoshi Nakamoto vision of removing all intermediaries. So users on the internet computer authenticate, or can authenticate, there are different options, but they can authenticate using something called internet identity. And this actually leverages special hardware on your devices, like the fingerprint sensor on your laptop or Face ID on your phone. And you can essentially use your devices like passwords. And what's happening behind the scenes is that cryptographic key material is stored inside special secure hardware on your device. And it's impossible to get that cryptographic key material out of that hardware, so it can never be stolen. And this provides an enormous step forward in terms of usability. When you interact with a Web3 service on the internet computer, you simply create a session by using your Face ID or pressing the fingerprint sensor. If it's a very security sensitive service, you might use something like a Ledger Wallet or a YubiKey. Everything is supported, and it all works through all the major web browsers. If you're really interested in understanding the possibilities that have been created by the Internet Computer, have a look at the Open Chat service. It's a messaging service that runs entirely from the blockchain. Smart contracts are processing chat messages and media messages, such as images and video. And all of those messages are stored on the blockchain, the Internet Computer blockchain itself. And very soon, this service is going to assign control to a community DAO and run a decentralization sale where the proceeds are kept by the DAO. And this is really an example of a social-fi service because chat accounts are also crypto wallets, and you can send crypto with chat messages. You might be asking, how on earth was all this made possible? The answer is through an absolutely huge amount of R&D. The Dfinity Foundation has built one of the biggest R&D operations in blockchain, probably the biggest, frankly. We employ tens of cryptographers, for example, and we've developed capabilities that have allowed us to really push the boundaries of what's possible. And I invite you all to go to the Dfinity Foundation website and have a look at some of the amazing people working as part of the Dfinity team. These are the trends coming up: DeFi, SocialFi, GameFi, and the metaverse. We're seeing all of them on the Internet Computer. And frankly, we believe none of these things can ever reach their full potential without a real-world computer. If you're a developer or an entrepreneur, consider joining the thousands already building on the Internet Computer. Everybody building on the Internet Computer is really part of a movement to realize the Web3 dream. And this is going to transform today's internet ecosystem and put users in control and make them part owners of these services, as well as part of the teams that run them. It's an incredibly important movement. Here are some of the projects being built on the Internet Computer that aim to provide Web3 alternatives to Web 2 services. Something else which is important is that the Internet Computer is designed as a complete replacement for traditional IT. In the end, we believe even enterprise systems will be rebuilt on the Internet Computer. And this is going to make Internet Computer skills very, very valuable in the future. This is a huge opportunity. Gartner says in 2022, the world will spend $5 trillion on traditional IT. The world will spend $500 billion on cloud computing. And the world will spend $172 billion on security. And when you think that when you build on the Internet Computer, you don't need firewalls to protect the system, that gives you a sense of just how disruptive this network could prove in the coming years. Today, awareness about the Internet Computer's capabilities isn't that great. Less than 0.5% of the blockchain community is really truly aware of what the Internet Computer represents and what a world computer is. Please help us spread the word. Be an Internet computer and Web3 pioneer and help us drive awareness up to 95%. Please become part of this project. Thank you so much. Enjoy the conference.